substance which occupy space and have mass and volume is called matter. Matter is made up of small particles. This idea was given by Greek philosopher Democritus in 440 BC. Matter is composed of atoms that cannot be further divided. Atomic theory of matter in 1808. John Dalton proposes famous theory. It is called Dalton's atomic theory. But no experimental This is the theory of Dalton's. Different elements have different types of atom. Chemical reaction occurs when atoms are rearranged. Chemical reaction occurs only when atoms are rearranged. This is the theory of Dalton's. He explained by the three famous law of conservation of mass, law of multiple proportion, and these are the scientists who attempt at the different time. John Dalton's atomic theory, Michael Faraday electric nature of matter. Michael Faraday proved Michael Faraday experiment. When electricity passes through an electrolyte, then Michael Faraday saw that when electricity passes through an electrolyte, mass deposited in the electrode. He concluded that charged particles have mass. From this phenomenon, he concluded that charged particle has a mass, but structure of atom is unknown before the experiment of William Crookes studied the discharge experiment in 1879. Crookes observed that gas conducts electricity at low pressure. We know that solid can conduct electricity, but Nicholson proved that liquid can conduct electricity. Crookes, this is called discharge experiment. This is conducted by William Crookes. Crookes conducted this experiment. When electricity passes through a low pressure, then it conducts electricity. This is a Crookes discharge experiment. This is how flow the Crookes experiment. Crookes designed this experiment at low pressure. He placed two plates at the two ends of the tube. One is connected to negative terminal and other is connected to positive terminal. Negative terminal, which is called cathode, and positive terminal, which is called anode. But this phenomenon observed by J.J. Thomson. J.J. Thomson placed a wheel, and he saw that the ray can push push the wheel. This is how he placed Ray push the wheel. So J.J. Thomson conclude that push the wheel. He conclude that it is consists of a particle. Place an obstacle and found a shadow, which proved that the ray is stable in a straight line. Ray stable in a straight line. First, he proved that the ray is a particles. Ray is a particles. Then he proved that he applied electric field. Then he showed that the ray moves towards the positive terminal. He concluded that this is a negatively charged particle, as the ray created from the cathode, and named this ray as cathode rays. This cathode ray is actually name given by Crookes. J.J. Thomson given the name of the particle, negatively charged particle, which is electron. So this is how electron discovered. He also determined the mass of the electron. Negative terminal moves toward the negative terminal. This is how the electron discovered. J.J. Thomson described an model of atom. He concluded that as atom is neutral, if electron is negatively charged particles, so there must be a positive charged particle. Positive charge unknown to the J.J. Thomson. He imagined that as atom is neutral, so there is a positive charge particle inside the atom, and he designed an atom model, which is called plum pudding model, like that of watermelon. Seeds of the watermelon distributed equally in the different part. So atom, electron and proton are distributed within the atom. And electron and proton, positive and negative charge, are distributed in the atom in the whole space. This is how the structure of atom is explained by J.J. Thomson, like that of watermelon. Plum pudding model. This model is called plum pudding model. But lifetime is not covered. Further study. Next, scientist Ernest Rutherford. Goldfield. This experiment is called Goldfield. As gold is malleable metal, he prepared a thin sheet of goldfield about 0.04 mm and strike alpha particle, which is positive charged particles. So I observe what is the experiment of Rutherford and what are the conclusion. When alpha particle pass, then most of the this is Goldfield experiment, striking alpha particle. Most of the ray passes to the nucleus, passes to the Goldfield, and some rays are totally back 180 degree. This is the Goldfield experiment of Rutherford, striking positive charged particles. Thomson-Raton model. This is the gold hole experiment. Some rays are totally back 180 degree and some are deviated. Most of the ray passing. This is the ray back. When one ray back totally 180 degree, this ray back total 180 degree. One ray out of 2000 rays, one is back totally 180 degree. This confused to the Rutherford why it is back. As one ray is totally back, Rutherford conclude that the positive charge particle somewhere concentrated in the atom. This he conclude that he named that nucleus. That is, as explained by J.J. Thomson, electron and proton are distributed in whole space of atom. From this observation, Rutherford conclude that protons are not distributed, protons are concentrated at the somewhere in the atom. This position is called nucleus. So Rutherford conclude that if electron is stationary and positive charge protons are concentrated at the center, then positive and negative charges are attacked, and finally electron close to the nucleus, so it must be revolved. He compared to the solar system, sun at the center, so nucleus at the center, and electron revolved around the nucleus. This is the model of Rutherford. How electron revolve around the nucleus. So in this way, electron are revolve around the nucleus and positive charge which is at the center. From this experiment, he concluded that these attraction, centrifugal and centripetal force are balanced, and he compared this with solar system. And electron revolve around the nucleus and positive charge which is at the center, which is called nucleus. This is the model of J.J. Rutherford. As electron revolve around the nucleus, it loses energy and ultimately fall into the nucleus. So this is the drawback of Rutherford lifetime not cover. To explain further, but Balmer designed an experiment with series of spectral line. From this spectral line, he observed it's from spectral line, Balmer spectral line. Niels Bohr. This is what Niels Bohr explain electron revolve in a certain specific path which is called orbit. So this is the ultimate model of atom.